Hello everyone, it's Matt here and welcome to episode 6, read it, 2 hands, 6, of the Ryzen R7 1800X build. Now the reason why this video has been a bit later than the previous videos, such as the ones unboxing stuff and the actual build itself, is because I wanted some experience of Ryzen underneath my belt so I could give a proper review of how the build has gone. So obviously after the build there was the installation of Windows 10 Pro, there was obviously the installation of certain apps to get myself back up and running, rediscovering the Steam library, and there was a few other bits and pieces as well just to make sure everything was working properly, including some of the movement of games over. So there are some games on the standard platter drive which I wanted to move on to the single platter drive, so I could then move and also move some of the stuff off the old platter drive I was in storage over to the NVMe drive for games storage, so that things like Battlefield 1 and Overwatch and a few other things like that could load just like the snap of your fingers. For some of the maps on Overwatch, for example, it's actually loading the whole match up to the hero selection screen in about 2 to 3 seconds from start to finish. It's that fast, which can kind of be expected considering it is a console level game, and obviously because Blizzard is in the esports scene, it wants to try and get a game that is really fast but still moderately detailed. So that's why Overwatch is possibly a good example and also a bad example for how fast games can run on a system. Battlefield 1 on the other hand really does tax the system quite a lot. It's a multi-threaded application, so it can use more cores. It really does beat on a system when it's in the middle of a game, because obviously it's trying to do quite a lot. It's obviously trying to simulate the people themselves and the soldiers, and the soldiers themselves are actually fairly detailed models. There's actually they're quite high in polygon count, and there's quite a lot of animation to them. And obviously, even if you're on your own as a soldier, it's still trying to simulate the surrounding journey. So that's brick walls that can collapse, roofs that will get shot off by tanks, and various things like that, which can be really taxing on a computer to simulate all at once. So from that perspective, the Ryzen build has gone really well. I'm not exactly seeing that much of an improvement in terms of frames per second or anything else compared to my old ep6 build. So that was Artemis. But what I'm seeing with Apollo compared to Artemis is that there's a lot more stability in the system in terms of frames per second. So not necessarily an improvement, but I'm also, I'm not seeing an improvement in terms of actual just general FPS, but I'm seeing a huge improvement in the base FPS, and in addition to that, I'm also seeing games load a lot quicker and just generally act quicker because there's more punch in Ryzen than was for the FX8350 build. So in addition to that, I'm actually going to talk a bit about the comparisons between Artemis and Apollo, and the way I'm going to do that is actually through Cinebench. So I'm going to change the image now, so bear with me. So the first thing we're going to look at is the difference in performance between Ryzen at 2933 and the FX8350 running on the old system. And the reason I'm running 2933 is because that's the most stable RAM configuration, that's the highest I could get. I could set the RAM to 3200, but the issue is once I do a reboot, or if I turn it off and turn the computer back on, the BIOS doesn't actually like running at 3200 from a cold boot, so essentially the system's only stable at 2933. So the numbers in front of you are the various benchmarks available within 3D Mark, as well as the various scores for running on the old system, which was Artemis, which was an FX8350, 16 gigs of DDR3 memory on some sort of Asus motherboard. I think it was like an R2 Duo or something like that. And then the same benchmarks run on Apollo, both on 3200 speed DDR4 memory, and same memory again running up to 2932, which is what this video is actually recording on now, which is 2933, which seems to be stable. There seems to be no issues, no blue screens or anything like that, running up to 2933. So on the most right hand column is the level of increase at 2933 from the original Artemis benchmarks. So you can see that Fast Strike gets 105% increase in benchmarking, but that decreases quite immensely with regards to Fast Strike Extreme, Skydiver and Time Spy. And you can see there that in actual fact the difference between them is between essentially 12 and 29%. So the increase in performance that Ryzen yields doesn't actually translate that well in terms of benchmarks. And I should point out here, we're talking about going from an 8-core 8-thread CPU to an 8-core 16-thread CPU, and in addition to that you've got a new chipset to power the new DDR4 socket, because it's an upgrade from, not DDR4, an upgrade from the AM3 Plus socket to AM4, so it's new compatibility for DDR4 memory, so that upgrading from DDR3, and there's a few other things intermixed which have changed. I'm still running on an SSD. The stuff is still stored on a plasma drive. Essentially there's very little change except for the motherboard, the RAM, the CPU, and if you want to go into particulars, the thermal paste. But everything else, the graphics card, the PSU, the drives are essentially are the same or an equivalent as the old system, so there's not going to be that much change in that respect. So has the Ryzen change actually yielded any better results? Well, yes. FPS in actual gaming doesn't seem to have been changed that much. I was still getting fairly stable frames per second on my old FX 8350 system, which is a Artemis enabled here. Artemis was able to do Battlefield 1 on Ultra on single player without any issues. Multiplayer was struggling slightly, but I think that was more to do with the graphics side rather than anything else, which is what the benchmark would seem to indicate. It was still able to do video encoding fine, and essentially until the middle of March, when the Build R2 video came out, all the videos before then were all done on Artemis, so you're looking at everything being done on 8-core, 8-thread CPU, with 16 gigs of memory, encoding and all the gaming and everything else went through that. And I've jumped from 8-core 16-thread with 16 gigs to 8-core 16 threads with 16 gigs of memory. So the memory hasn't increased, but the thread count has doubled. And that's not yielded exactly a great improvement in actual performance, but it has increased baseline performance. So I'm seeing less of an FPS drop in more intensive areas. My minimum FPS has increased slightly, or increased massively in some instances. Well, what I will say is that I've personally not experienced that much of a bump in performance that I was actually expecting from Ryzen. However, that's more related to gaming. In terms of actual encoding, such as media production, actual things that require computational power, the increase has been phenomenal. Windows Movie Maker, for example, took minutes sometimes to import videos, and with Ryzen, even though I'm importing could be importing considerably more, it's taking a far fewer time because there's more cores available, so it can actually running at, I think it's a lesser speed, but because there's more threads, it's actually churning through the videos quicker. There's a really good performance increase on that. So essentially everything since the middle of March and the Build R2 video, everything from the Build R2 video to the present day has all been edited on the Ryzen system, which is I've called Apollo, which runs, as I mentioned, an R7 1800X with 2933 speed, and it seems to be churning through everything very well. You can see that the increases we've got are fairly good, but I think once Vega comes out and I can afford it and I can upgrade to Vega, that the performance will dramatically increase compared to this, because it will have the HBM2 memory, and essentially it will just fly through some of the benchmarks a lot faster and a lot better than we've currently seen. So another thing I want to talk about while I'm on this is actually the difference in RAM performance. You may have seen mention of the difference in performance when you're comparing Ryzen at different memory speeds, and there is truth to that. On the flip side of that, however, the actual increase in performance with RAM speed, I've not actually seen that much. Basically, all ties down to something called the Infinity Fabric, which is the new CCX for Ryzen, or the Zen processor range. And basically, the Infinity Fabric is the layer of the silicon that allows the various bits of the CPU to talk to each other. So basically, the cores can communicate with each other what they're doing, and if they need to pull in more power, if it needs to put off the process onto something else, etc., etc. That Infinity Fabric is actually tied into the RAM speed. So essentially it runs at half the RAM speed. So if you increase your memory, you increase the CCX. Essentially, increasing RAM speed yields an increase in performance on the processor side. So for conventional systems, if you increase the RAM, you just increase the RAM throughput. With Zen and Ryzen, essentially what happens is you increase the RAM speed, you also increase the speed at which the processor can operate at, and you actually get a much more better you actually get 5 to 10% more performance out of Ryzen by doing that. So as such, you do get an increase in performance with more memory, but you don't actually gain that much of a performance increase in terms of things such as gaming or anything else. And in actual fact, I've actually seen not exactly a degrade in performance, but no actual boost in performance jumping from certain RAM speeds to higher ones. So it could just be that in actual fact RAM speed does help Ryzen, but in terms of actual noticeable performance, I personally have not seen anything. But what I will do now is that I'll move on to Cinebench, and I'll actually run the CPU test. As you can see in the OpenGL test, I was getting about 97.97 FPS, which is reasonable, but again, that's more tied to the graphics processing, which I think is now the letdown with Apollo rather than actual processing power. And this, I'm not speeding up or slowing down the video as evidence because I'm actually in it, which is actually why I'm on camera in the corner. So this is Ryzen running out, and you can see there it goes to Cinebench value is 1543, and that's actually a slight increase to the previous benchmark, which was 1519. So as you can see, there's a slight performance increase once the CPU and the silicon gets up to a bit more sort of like within the operating temperature range, but this is a really good value. But essentially it's something to sort of say, yes, it's really good, but you know, it's again, it's a benchmark. It's something to sort of say, yes, it's good, but you know, essentially it's a value. I can compare it with X, Y, Z, but benchmarks, and I will say this is a disclaimer, and you can apply this to any benchmark. You can't do a straight comparison unless you have reference boards, same memory, same graphics card, because the CPU is part of an entire ecosystem of the computer. So the RAM is the CPU is reliant on the motherboard to allow it to connect to everything. It's then also reliant on the RAM to transfer data in and out of the hard drive and to write data to and from on a processing level. It needs to go from the motherboard. It then accesses the system storage, where it's got the operating system and the programs it uses and the data it reads and writes to in terms of long-term storage and everything else. So benchmarks essentially sort of say how good something is, but you can't do a straight apples to apples comparison because you're using different motherboards, because they all have different sockets. You might be using different memory, even though it's the same speed. It might have different latencies. It'll probably come from different factories, so it might have different silicon characteristics, etc., etc. So benchmarks are one thing, but you shouldn't take them as is. You should always treat them with a pinch of salt. Personally, I always look for, and I'd urge anyone to, if you're looking at benchmarks, try and get as many as possible to try and get a more aggregate score, because one benchmark might say one thing, but your average person going out and buying something will probably get a different result, and might not even get the results that the reviewer got, because the reviewer might have been sent a nice cherry pick sample which the manufacturer knew worked well, or alternatively was known to be a good working sample, so they might have gone that and sort of said, here's a good working sample, review it and post your results. Whereas something you might buy on the street might not be as good performance, but is still the same product. So you can see from this that Ryzen gives a nice boost of performance to to older processors from the previous processor ranges. So lastly, I want to talk about, should you buy Ryzen, and should you upgrade from it if you've got a previous AMD system, or if you've got a previous generation or a couple of previous generations Intel system and you're looking to upgrade to AMD because you've heard about Ryzen. What I will say is that if you're going to go for the Ryzen R7s, you're a bit of a fool, because unless you're doing heavy media encoding, heavy editing, or something like that, you're essentially burning money, because the performance you get out of an R7 1800X or 1700 or 1700X, which are in the R7 range, to be honest, you're probably not going to use effectively. And I say that with some certainty because I've looked at Task Manager when running Battlefield 1 and a few of the applications, and it's not actually using all 16 threads. So that level of performance you don't specifically need right now. What I will suggest, and feel free to ignore it, feel free to look into it, if you're looking to get a Ryzen system, go for, take it from me, buy a decent motherboard, buy some decent memory, but go for an R5. And there's a very good explanation why I say go for an R5. Basically, you've got two things. Right, Zen at the moment is the first iteration that's currently available. Zen Plus and Zen or Zen 2 is coming either towards the end of 2017 or the start of 2018. That means that in a year's time, at most, we'll know, if not have access to, the next generation of Zen, which means that you'll have better performance, better stability, better RAM support. You might even have generally available motherboards with quad-channel support in the domestic market, which you can go out into any shop and buy. Because the issue at the moment is that quite a lot of the motherboards are only dual channel, meaning that they only operate effectively, or most effectively, at a dual channel level, which means 2 RAM sticks. And if you know memory, it's not capacity, it's how many sticks you've got that affect it, because it's to do with I/O rather than capacity. So if you have more memory sticks, you get more performance than you do having fewer sticks of a higher capacity, essentially. So essentially more memory sticks yields better performance. The second is that the DDR4 socket, which Ryzen is based in, is here to stay for at least the next 2 iterations, possibly more. So DDR4 is going to stay around for another 2, 3, possibly even 5 years. So even if you get into the AM4 ecosystem now, your motherboard, providing it's still good on a hardware level and there's no major problems with it and it's all working fine, you can upgrade your CPU once, twice, possibly even 3 times before your motherboard then becomes obsolete, and AMD moves on to another socket or possibly a new chipset with more features, etc. So my recommendation is to, if you're looking to Ryzen, I'd wholeheartedly recommend it. It yields very good performance for its money. The value is definitely there because it's being in some instances Ryzen CPUs are being compared to Intel CPUs, which are twice the price, or possibly even more in some cases with the 1800X. The cravat with that is that unless you need that raw performance of a R7 from the Ryzen range, because you're doing heavy media encoding or 3D modelling or stuff like that, go for an R5. You'll save some money, which you can invest in later things or just save generally. And to be honest, you're probably better off getting an R5 now and then upgrading later, because you know you've not wasted your money. And then you might even find that you buy an R5 and you don't actually need to upgrade because the R5 does everything you need to, because you don't need that extra performance. And R5s are very competitive with the Intel i5s and possibly even in some cases the lower end i7s. So what I will say to you is, look at what's available. If you're looking into Intel, please bear in mind that Ryzen is here. It is a very good system if you're looking into it from AMD. But essentially, you know, even if you don't want to upgrade to Ryzen now, Ryzen Plus or Ryzen 2 is coming end 2017, early 2018. Keep an eye on, keep tracking Ryzen, have a look what AMD is doing, because Zen Plus or Zen 2 will probably solve a lot of the issues we've actually seen with the original Zen release. And that's it for this video, and that's it for the entire build. I will be posting another video which is all the original episode 7 content, which I originally recorded when I was installing the OS as sort of like a goofs reel, or sort of why I didn't upload it reel. But essentially that's it for the build. If you got any questions, please put them in the comment below and I'll try and answer them as best as I can to my technical and physical ability. And that's all from me and Apollo for now, and I'll see you in the next video. Bye.